Listen to this. Write cloud applications the way you write local ones, then compile them into cloud native ones, because microservices are the assembled code of the cloud. Now that's confusing, even though that's actually the sentence from the product that I'm going to show. So let's backtrack for a second and explain what are we going to try to do today and what are the problems we are trying to solve today. And then we go into a surprise project that I think you might like. To run applications, we need to figure out how to compile them and how to package them. We need to create infrastructure. We need to define how will an application run on top of that infrastructure and what its dependencies are. We might need to modify the code of our applications so that they can run on top of that infrastructure. Now, if you're an ops person or cloud person or Kubernetes ninja, this might be easy for you, but for many people, that's not the case. And many people turn to managed services to simplify all that process. That can be AWS Lambda or Google Cloud Run or Azure Container Apps and so on and so forth. And with managed services, we do not need to bother with infrastructure. However, we still need to define what our applications are, how they communicate with each other, what the dependencies are, and most importantly, which service they will run on. Will that be Lambda? Will that be Kubernetes or Google Cloud Run and so on and so forth? Even the best managed services require certain amount of work and this is now important, domain knowledge. Even if we use those, we still need to figure out which service best fits our use case, and that requires extensive knowledge and experience. But how about this? How about getting all the benefits of cloud, but focusing only and exclusively on application code and forgetting almost everything else? How about we tell some system, some platform, what the requirements are, and have a system that will figure out whether those requirements should be met by Lambda or Kubernetes or any other managed service? How about the system figuring out whether there should be a load balancer, storage, or any other dependency based on simple requirements? How about not caring about anything but the code of an application and what those requirements are, and letting a platform of sorts figure out everything else? In other words, here's the code, you do whatever needs to be done to run that code, to convert it into application, to put it somewhere, to choose where that somewhere should be, to figure out all the requirements like disk networking and so on and so forth, and just say, that's it, right? Here's my code, go. And today I have a platform service that might do just that. Let's explore Klotho and see it in action first and then talk about it, because there are good sides and bad sides. But first, let's see how it works. For now, just remember, the product is called Klotho. I hope I'm pronouncing it right. I'm not sure. If I'm not, then somebody needs to correct me. Let's take a look at source code of a relatively simple and straightforward application. It's just a source code of, I think it's JavaScript, right? TypeScript, to be more precise. So here's index.ts. There is nothing special about it. It is importing Express. It is having a couple of constants, one for users API endpoint and video list API and video post API. And there's not much more, really. It is listening on port 3000. It's a simple application with a couple of endpoints. Nothing special about it. There is absolutely nothing special about it. And then there are a couple of other files like user.api.ts, which is just listing all the users in the system. It is intentionally simple, nothing really special, because we do not need a complicated application to demonstrate what I'm going to demonstrate. What matters is that this is only the code of application. You might be able to spot one thing that is special, but if you do, great. If not, we're going to comment on it later. And the same can be said for video post API TS file and video list API TS. And last one, I promise, this is really the last one I'm going to show you. It's called videodb.ts, and yet another JavaScript, TypeScript file. Nothing, still nothing special, nothing at all. And I can prove that there is nothing special about it by running that application. So let me run it with the tsnode command, and then the file that I want to run is index.ts, and we can see from the output that application is listening locally, it is running locally. And I can prove that that's really true by sending a request on localhost 3000/v1/users, and I get a couple of users over there, and I can post some data to /video endpoint, and I can retrieve data from /video as well. So 3 CURL commands that prove that my application is running locally. Now bear in mind that this application is not having a local database, it is not storing data locally or doing anything special, it is ephemeral. The moment I stop running it and start it again, I would start again with the new data from scratch, right? So this is now running locally without being connected to any persistent volume, without running anywhere except on my laptop. Now let's see how we can move that application, which I repeat has nothing special in it, into cloud, without really deciding how it should run there. The only decision I will make is that it will be AWS. It could be something else as well. So let's start by exporting app name variable that will give it a unique name for this application, and then execute cloudcc compile. I will specify that the run environment is AWS. The name of the application is whatever it is. The output there is compiled. That's where I will compile that application, and it will use TypeScript to compile it. And finally, the root file is index.ts. So I'm compiling the application using something called cloudcc, which is CLI of Klotho, which we will see later. For now, the only thing that matters is that we are using special way to compile application that otherwise has nothing truly special in its source code. And the next thing I need to do is put that compiled version into AWS without doing much more. So I'm going to execute cloudcc up, give it the directory, work directory where the compiled version of the application is, and give it some name, whatever the name is. And then let cloudcc figure out, actually it's not cloudcc is the CLI, but the product is called Klotho. Anyways, I'm going to let it figure out what to do with my otherwise ordinary application. And if you focus on the output, we can see that among other things, it created Pulumi manifests. So it is using Pulumi, even though it doesn't have to be Pulumi, just to clarify, but by default it is. So it figured out what it should do with the application. It generated some Pulumi manifests, and now it is executing Pulumi and making all the infrastructure and quite a few other things that are required to run that application. And I can watch the progress from the terminal, or I can open that address and go to Pulumi itself to see what's going on. Now, once it's finished preparing whatever it needs to prepare, it asks a simple question: do you want to perform this update? Of course I do, otherwise why would I do all this? I mean, it's nice to see what will be the output, but that's not really for the type of the user I expect to use something like this. This might be too much information. Anyways, yes, I want the update, and then I will let Klotho do whatever needs to be done to run that application wherever it needs to be running, and I can see the progress in Pulumi itself, or I can continue monitoring the terminal. Either of the two is fine. I just need to be patient and wait for a couple of seconds. Maybe more than a couple of seconds though. And that's it, it's finished. And it says, hey, it's finished. There is the output, and output says, this is the API URL. This is the URL through which you can access your application. So I'm going to copy that URL, and I'm going to export a variable API URL so that I do not need to memorize it, and put whatever the URL is over there. And now I can repeat the same request, same CURL request as before, but this time the application is not running locally, it is running in AWS without me specifying what it should do and how it should get there and what I want to do with it. Let me send CURL request to /users. That works, I got 3 users. I can send a request to post request to videos, and actually video, not videos, and then I can see that that works, and I can retrieve all the videos, and that works as well. My application is running, just not locally anymore, it is running in cloud. Without me writing a single line of Pulumi code or Terraform code or anything like that, it just runs because Klotho or Cloud CC figured out what the application is, how it should behave, what is the best place to put it, whether it should use Lambda or Kubernetes or something else. In this case, it's Lambda, but it could be some other technology, some other service. It figured out everything. All I had to do was compile it and say, up, go there, go up to the cloud. Now that I mentioned compilation one more time, you can see what really happened by going to the compile directory, and you can see some Pulumi files over there. You can see source code of the application itself. It's not the same as what you wrote because Klotho modified the application by adding special instructions to it and so on and so forth. It created quite a few things, all the things that are required to run our application successfully. In this case in AWS, but it could be something else. But what I really want to show you is a picture, because picture will give us an idea what's really going on there. Look at that. This is what Klotho created. It created 3-4 lambdas. It grouped all those lambdas into an application. It created storage for that application because it turned out that some parts of the application need storage. It created some scheduled operations, scheduled cleanup, and so on and so forth. So it created quite a few things for such a simple application. Now in a real world scenario, it would be even more complicated than this. But the point so far is that I can focus on writing code of my application and ignore everything else. Just let Klotho figure out what to do with infrastructure services, where it should run it, how it should run it, and so on and so forth. And that's potentially amazing. And if we open index.ts from the compile directory, we can see that our source code is not the same anymore. Klotho added quite a few additional instructions, all the things that are required to run an application in certain service, in AWS in this case, using Lambda and this and that, and how to connect them all together. There's a lot of things that we would need potentially to add to our application, but I didn't, Klotho added it when it compiled it. So it created Pulumi manifests to create all the infrastructure, everything that is required in AWS, and then it compiled the application, source code of the application into a different source code, the source code that is required to run it, in this case as Lambda, and then it just went there. Now there is one thing that I should say, and that's that I cheated a bit. I said there is nothing special with this application, with the source code of this application, but actually there are a few things a bit special, and those few things are comments, to be more precise, requirements of sorts. So let's take a look at index.ts one more time to see that special thing. There's comment that says capability is HTTPS server. That told Klotho that there should be a server somehow, and that function should expose itself through that server. I'm not telling Klotho which server should be, how it should run, where it should run, and so on and so forth. I'm just saying, hey, you figure out what is needed. I'm just telling you that one of my requirements is to have a web server somehow. Now let's take a look at yet another one, the second file, which is user API. And that one is also just slightly, a little bit special, is that it has that comment at the very top, the first line that says topology group is user API. That is telling Klotho that there are different groups or segments or parts of the source code that should be separated when it runs into different groups of functionality, right? And this one is called user API. And then if we go to video post API file, again, there is nothing special except that first line that says, hey, this is a different group, different functionality that is going to be called video post. And the same is the case with video post API that has that comment that says, hey, yet another group or functional group within my application. And then the same thing is happening in video list API file, yet another group, boring, let's move on. And finally, this is, I believe, the last one that says, hey, yet another group called QRender, nothing really special, but there is a second comment over there that says, hey, but this one is a bit more special than others. It has additional capability that says, hey, schedule this to run every 5 minutes or 5 hours. I'm always confused with cron job syntax. Anyways, schedule this to run. So every once in a while, scheduled cleanup should run. And how it should run, which type of services should be, again, not my problem. Oh, there is another one, and this is important one called VideoDB. Over there, we have yet another new capability that says KV, key value persist, and it should be eventually consistent. What that means is that this part of the application should have a persistent layer. The data should be persisted somewhere. I do not know where, I do not know how, I do not care about those things either. What I do care is to persist the values that are in this variable, in this map. I do not want it disappear, right? Basically, essentially, all that I did, apart from writing the code of the application, which, by the way, it's not, I did not write that application. This is application that was written by Klotho team itself. I'm using it here instead of writing and using my own application. I do not have my own application yet. I will explain why that is the case later. For now, what was I about to say? Yes, that's all I did, right? I wrote the code, or I stole the code of an application. I wrote a couple of requirements, which are just comments in my application, and that's about it. Code plus simple requirements, like, hey, this is a web server, this should be persisted, and so on and so forth. And that's all there is to it. And if you get bored and if you say, hey, this is a demo, this is a tryout, I do not want to keep that running, we can just execute cloud cc destroy, and then Klotho will destroy things that were running before, right? I mean, you shouldn't be destroying applications in production, but you might want to destroy them if you're trying them out. So there is that option as well. It can create, it can destroy, and I still do not need to specify anything except a few requirements. Now let's talk about Klotho. Should you use it? What are the pros and cons? Now, Klotho is in very, very, very early stages. It went public only a month ago or 2 months ago or something like that. It was closed beta for a while now, but it's still in very, very early stages. So it has a lot of negative things, a lot of things that shouldn't be there, which I'm going to comment, right? Because that could be important, or it might not be important at all. We're going to talk about that later, but let's talk about negative things. And to begin with, it depends on Docker. Now, I'm not trying to trash Docker and say, hey, Docker this or Docker that, but simply put, not everybody runs Docker. I do not run Docker. I had to install Docker for this. And if the requirement is to have containers, then this is a message to Klotho folks. Hey, containers run in Docker, but they also run with Rancher Desktop. They also run with many other tools. So if you want containers, run containers. Don't run it in Docker. Now, you already noticed that it is using, among other things, Pulumi behind the scenes. And I had to install Pulumi on my laptop, actually on my desktop. And that's kind of strange, because if it requires Docker to do things, then it shouldn't need Pulumi as a local dependency. Pulumi could run in a container as well. So if the choice is to do some things in containers, then do everything in containers. Then I don't need to install local dependencies unless I really, really want to install them. Now, the third thing are docs. Docs are missing a lot of things. There are even some things in promotional video of Klotho that are not documented at all. So if the project is in early stages, then docs are in whatever would be qualified as before early, right? Docs are really, really short and not very descriptive and not very, very informative. But again, it's early stage project, right? What else? Oh yeah, today it works only with AWS and Google Cloud. Somehow AWS for real, Google Cloud more or less. Now that will change in the future. Klotho will add support for additional providers. So again, early project, right? Very, 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 very green. What else? Yes, it works. And now comes the reason why I'm not using my own app, or source code of my own app. I prefer writing in Go, but Klotho today supports only JavaScript. Java and Go support are coming very, very soon, and then other programming languages. So instead of me learning again after many, many years of not using JavaScript how to write an application in JavaScript, I stole it from them, right? Now you know the reason why I didn't write my own source code for the demo application. What else? Oh yeah, within AWS it supports only Lambda, right? But that's not the goal. It should support many different services and choose which service best fits the needs of your application. But today that's only Lambda, and generally speaking, it does not do much yet. Now, what we need to see is what it will do in the future. Remember, this is a project that just started, so I'm more focused on the potential of the project than what it does, because it doesn't do much yet. Now, there are some pros, quite a few things that I really like. And to begin with, I really love the idea of focusing on the application, on the source code, and not on infrastructure. There are no SDKs and libraries or anything else that we should import. We just write a few requirements as comments and that's it. Nothing else, right? And we do not need credentials for the cloud because everything is happening from the terminal. So focus on application source code, no SDKs, libraries, and so on and so forth. No credentials for cloud that we are using. We're not sending it to anybody. And finally, everything that Klotho produces is based on open source. Now, Klotho is not open source itself, which I'm not sure how I feel about that, but the output of Klotho is open source. There is nothing hidden from the output that it produces. So you could take it tomorrow and do it without Klotho, right? Because you get the source code of everything that you need to run that application after you compile it. Now, here's what I really think about Klotho. I think it's extremely promising. This is very fresh. This is a different approach to how we manage applications and infrastructure and services and so on and so forth. So it is extremely promising. It's in very early stages. I would not recommend using it for your production today. I mean, you could try it. I know that there are a couple of companies using it in production, but for majority of us, it is still very green, but extremely promising. This is a project you should be watching. This is the project you should pay attention to because it might become awesome in the future. But to become awesome, I need quite a few things to happen in a project. I need additional providers. As a minimum, I need Azure being supported there. I need additional resource types. It cannot be only Lambda or functions. It must support Kubernetes and ECS and GCR and so on and so forth, so that it has a bigger pool of services, so that it can make right decisions what to do and how to do it and so on and so forth. I need additional programming languages. I need Go. Other people might need Java, Python, and so on and so forth. I need support for additional tools because operations people, SREs in my company might not be using Pulumi. They might want Terraform or Ansible or Crossplane and so on and so forth. And Klotho should be able to give me output in different formats so that I can maybe plug it into some other processes that I'm using. And finally, and this might be the most important thing, I need additional control for operational sides. I need to be able to tweak Klotho and give it additional information like, hey, you might be choosing to run this like that, but in my company, in my organization, there are special requirements and special way to do things, so let me tweak the output a bit. Now, all those things that I mentioned are on the roadmap, so they're coming. At least that's the promise. It is coming. Again, it's very early, but it will come probably if the project continues as it will continue. So here are the three takeaways. First, extremely promising but green project. Second, I'm waiting for the support for additional providers, resource types, programming languages, and so on and so forth. I'm waiting for Klotho to grow beyond this initial phase that it is in. And the big question is, once Klotho grows and starts supporting additional things that I need, will it increase the complexity and defy its own purpose, or it will continue being very developer friendly and still useful in a more complex setting? Time will tell, but for now, promising. Watch for the project. Thank you so much for watching. See you next time.